Since the first satellite was launched into orbit in the 1950s, little has been done to support the overall hygiene of Earth's orbit and cislunar space. In recent decades, more and more governments and commercial players have launched or made plans to launch their own space missions. Associated challenges range from clouds of debris to anti-satellite tests, through to tardigrades sprayed over the pristine lunar surface and everything in between. Enter the growing field of space sustainability. Without the ability to catalog, track, monitor, and mitigate space activity, operations in space will not be possible in years to come. Space missions won't be able to ensure clear paths for launch. Satellites may collide and create cascade effects, and debris will accumulate. Lunar dust can stay elevated for years. And the Kessler syndrome posits that the amount of objects in low Earth orbit will grow so dense that collisions between objects may become unavoidable, and the resulting space debris will trigger a cascade of future collisions. When we talk about space sustainability, we talk about the viability of our public and private space practices. We talk about proactive, maintenance, and reactive measures to clean up Earth's orbit. Perhaps more importantly, we talk about the future of humanity's ascension to the stars and the kind of species we aim to be. Space sustainability is at the heart of a new era that will growingly involve astropolitics. Today, we have the Space Force, UK Space Command, China, and other players reframing space as a contested domain. And this dynamic will only intensify in the coming years, necessitating a here and now understanding of how we will protect the environment of space in sustainable and scalable ways.
My name is Dr. Meenu Ratnaswapathy, and I'm a research engineer at the MIT Media Lab and also a project fellow working on the future of space at the World Economic Forum. So my focus is really at this nexus of technology, policy, and partnerships. And I think of sustainability both on Earth and in space through the lens of a shared principle of circular design. So really thinking about it as forming a closed loop system that integrates the stewardship of Earth, but also the safe and responsible use of exploration of space.
Hello, my name is Tom Berger. I'm the director of the Space Weather Technology Research and Education Center at the University of Colorado in Boulder. This is a center that is relatively recently incorporated here on campus to act as a focal point for environmental research in space, really, and how the space environment changes, of course, driven mostly by the sun and its activity, but also its impact on technologies that we have come to rely on entirely in the society that are space-based, GPS being perhaps the most well-known example there. And space sustainability comes into this picture because we really look at the environment, both its impact on the technologies, but the technology's impact on the environment as well, and how this increasing number of objects in our orbital space is becoming another factor that we have to be aware of when we're talking about the space environment in general. So both space weather, space environment, space sustainability come together here in our center at CU.
Thanks very much, everyone. And my name is Chris Bridges, and I'm an academic at Surrey Space Centre in the UK. And I'm part of a group of academics there that focuses on space engineering. So we've been working for sort of 20 years or so on how we use commercial off-the-shelf technologies actually in space for lots of different applications as well. And my group is the onboard data handling group, and that links with space sustainability in that how do we use perhaps big data? So I'm interested in perhaps noughts and ones across lasers, copper, RF, but how we can use either big data to then help us solve some of these challenges, but how then we might need to make then fast decisions. So how we might need to make then very fast computers to then make very quick decisions. And one of the things that I'd like to start with really with the group is perhaps, Tom, if you could think of what the implications really are for space congestion and what might surprise people that they don't perhaps know readily.
I always like to start with the story of the 2003 Halloween solar storms, as we refer to them, as something that people might not be aware of, particularly if they've come into the space field in the last 20 years, because it has been over 20 years now, well, almost exactly 20 years that it's happened. And the surprising thing is that when we get a large geomagnetic storm like this, a solar storm impacting the Earth, causing a geomagnetic storm, the havoc that it creates in orbital space is really quite surprising. And in 2003, the last time we had a very extreme geomagnetic storm, all of the objects in the LEO catalog were essentially lost for 2 or 3 days. Now, why is that? Because what happens when you get an extreme geomagnetic storm is the atmosphere actually heats up. The drag on satellites in LEO in particular, orbits between, say, 350 and 1,000 kilometers, become much, much greater than they were prior to the storm. And this actually drags the satellites down in altitude and forward in position as they speed up, falling into the gravity well. And essentially, they're completely off where the radar catalog had them just, say, 10 hours ago, before the storm really started. So the surprising thing is that to me, is that as space gets more congested, there is a possibility that in an extreme geomagnetic storm, we could lose track of all of the objects up there. And right now, one of the things that's really keeping us on track is being able to know where all these objects are, know where they're going to be, and plan conjunction analysis or collision analyses. That goes away in a major geomagnetic storm. But again, we haven't had that for 20 years. So I think people might be pretty surprised that that's even a possibility.
Yeah, thanks, Tom. Minnie, what about you? What's the surprising thing that you tell your students and research staff as soon as they figure it out, like, oh my God, is this actually where we're at now?
Yeah, and I just want to build on Tom's response there, because he talked about the increasing number of objects in space. And what's surprising to the public and certainly to us, even though we work in the sector, is that the number and frequency of launches of satellite is just exponentially increasing. So we know that more satellites were launched in 2022 than any year before that. And ESA just released their 2023 Space Environmental Report, and they cataloged more than 30,000 individual pieces of space debris that is larger than 10 centimeters that are currently that we know of. And most of them are in low Earth orbit, so below 2,000 kilometers. But the sheer volume of the objects that have not been tracked or are currently too small to track really are in the millions of pieces. So to Tom's point, as we think about our reliance on space technologies, you think about people in remote areas that use these satellites to connect to the internet, which is a basic human need. We think about the increasing coverage of Earth observation satellites that allows us to better understand and monitor the climate change. And we think about the economic costs of industries that rely on satellite technologies. It's really this balance of how many objects we have in space versus our reliance on these technologies.
And that's exactly the sort of thing that I sort of think about as well. So when I'm thinking about sort of space congestion and what might surprise people, there's kind of two things that jump to mind. The first isn't just that we have to track all these objects, is that actually we have to track them sufficiently well enough, that they don't have any error bars associated to them. So you might say, oh, we know where this satellite is, plus minus 5 kilometers. And you're like, well, 5 kilometers here, folks. These are huge distances. And it's not just then like how many then we track as well, that in actual fact, the ones that we do track, we often know very, very well. So those danger objects in LEO, we have many observations of them to prevent conjunctions or collision type events. But there's a good half of the catalog that we haven't tracked for over a year. And to me, this is also surprising that, the international community doesn't go, hold on, we haven't really looked at that object for over a year. And when we have geomagnetic events, whether or not they happen in our orbit, certainly for LEO, or whether or not they happen out at GEO, all of these things move, and we need to understand and observe these things, I think, with a much higher fidelity than we've got before. Because I think it kind of alludes to, as Tom said, something called conjunctions. And conjunctions are usually where we have these spheres of influences. So if you think of points in space, and we've got some spheres or spheroid-like objects around them, and when they intersect, those are our conjunctions. And of course, if they intersect a bit too much in actual physical reality, then we get our collisions. And the problem is that might cause something called the Kessler syndrome or the Kessler effect. And Minu, maybe you would like to tell us really what that is. And you know, are you worried about it, or is this just a thing that is so statistically improbable that you're not too fussed?
Oh, that's a great question. And I think people will fall in both sides of that spectrum, but also squarely in the middle as well. So the Kessler syndrome, of course, is the collision between objects and debris that creates a cascading effect. So think about where each object crashes into the other, generating more debris, which then increases the likelihood of even further collisions. So there's really two ways you think of this. And Chris, you mentioned, you know, large objects and then smaller objects. So we think about the short-term risks of collisions, so directly with active satellites, but also in the long-term risk of the Kessler syndrome, which leads to the breaking down of, you know, ESA calls this a cloud of smaller debris pieces that in the long term really threaten the damage to satellites. So we know that there are not enough satellites that leave these heavily congested orbits, particularly in LEO at the end of their life cycle. And then satellites also remain in their operational orbit at the end of the mission. So there is then a risk of fragmentation that then evolves into a fairly dangerous cloud of debris, which can linger on for many, many years. So I think that we should absolutely be conscious of the Kessler syndrome, whether it's at a point now that it is completely detrimental to the orbits that we use is questionable, but it's very similar to climate change. We need to act sooner rather than later, and there are certainly ways that governments and organizations are tackling the Kessler syndrome.
Fantastic, thank you. And so, Tom, do you think it's unavoidable, or are we not yet at that tipping point?
I think the honest answer is we don't know. As Manu mentioned, we don't track most of the debris in LEO. We only track the big stuff. And to your point, the big stuff has lots of uncertainties associated with it, either because we don't track it often enough, or ultimately the largest source of uncertainty is space weather in LEO. The environment is changing, the densities is changing constantly, even with smaller storms, and the objects are moving around. So as soon as an object leaves the radar beam, we don't really know where it is. And that's why we put these uncertainty bubbles around it. And we end up with lots of uncertainty as to where things are, and many more collision warnings than we would otherwise have if we could shrink those uncertainty bubbles. So we don't really know. There's things we don't know. We don't know how much is in LEO, how much debris is in LEO below about 10 centimeters. B, we don't know where anything is really. And C, we don't know if they're colliding, because at a certain scale, we can't tell if they're colliding or not. There are people in the operational field who believe that the Kessler syndrome is sort of slowly already happening. But again, that's just anecdotal, and we don't really have that information. So one of the things we need to do, and as a scientist, I always come back to this, we need to make more measurements for sure as to what is actually going on in LEO. So we need more radar, we need optical tracking, we need ways, creative ways of in-orbit measurement of what's happening up there to really know what's going on. But I also thoroughly agree with Manu that it's critically important that we get on this now, because it is almost a guarantee that if we ignore it, the Kessler syndrome will eventually happen. And when it does, that essentially means that an entire region of the orbital space is unusable, and perhaps even launches through that space are unusable. So every launch to every other orbit, including to the moon and Mars, has to go through the LEO band. And if that's full of garbage, then that puts extreme risks on anything passing through there. So it is imperative that we both measure what's going on up there better and start thinking of solutions for getting stuff that's up there down as soon as possible.
And if I may just add to Tom's point, I think that we see a lot of initiatives really trying to progress the technology when it comes to ADR services, so active debris removal services. We see an increasing number of commercial players who are demonstrating and offering these services to satellite operators. And then we see a number of commercial STM or tracking services as well. And that really all lends itself for end-of-life mission planning. I think it also lends itself to improved tracking. And we consider not just tracking, but what we call DIT, so the detection, identification, and tracking of an object if it can be done. And I think what we also need to encourage is data sharing between operators. So as much as allows, without sharing proprietary information, but certainly this international collaboration and coordination between actors will really serve to decrease this Kessler syndrome.
That's super interesting, and I think both of what you both said have really hammered the nail in hard there, and particularly on data sharing, because whatever we do statistically, like a good well-known object that is perhaps shared about, and actually many of the new operators tend to operate in a much more transparent way, multiplied by a bad statistical number is still a bad number. And so I think until we can find that equilibrium between perhaps regulation or legislation, without pushing people into, as you say, the sort of synonymous climate change problem, that until it's at your doorstep, it's kind of not your problem. And so for me, the thing that I worry about, certainly in if it's avoidable or not, is as Tom said, is how many measurements do you have on it? Well, if you don't know, then it's a bad statistical number that I can't really do anything with. But I worry also about then how much stuff actually goes on into much higher orbits as well, because either you care about time along one axis, or you start to care about numbers on the other. And as we see mega constellations that are picking up in the orders of, I think the most credible numbers of mega constellations, I think, totaled up to about 32,000 satellites just in really LEO. That's a big number. So for me, it's not necessarily it's a when. It's sorry, not an if. It's probably more of a when. And I'd probably agree it's probably already happening when we start to add up then just these sheer amounts of numbers that we may not know. And I think the thing then that we need to perhaps ask ourselves next is really what the risks are to people on Earth. So in the UK, the things that we take for granted, for instance, using Minu's example there around sort of Earth observation and weather monitoring, is that people don't die in certain countries that use this data really well, because we have advanced warning of storms, because we have advanced warning of how winds change, because we have advanced warning of how our seas move and the ocean states and the jet stream all moves. These things are critical for us to help predict then really what happens on the planet to then save lives. Are there any kind of prominent examples that you might have, Minu, on what risks there are to people that we wouldn't have necessarily had we not been using these sort of technologies?
Yeah, Chris, you have hit the nail on the head there when you talk about monitoring climate impact and sustainability. And one quote that I often like to say is 50% of our essential climate variables can only be measured by space. And I think that is a really interesting, but like a really poignant example of how space matters to understanding sustainability on Earth. So one aspect and one example I can give you is that at the Media Lab, we are looking at what we call the dual energy climate challenge. So thinking about the long-term equitable, accessible, cheap access to energy, which are really challenges all across the globe, but at the same time, also thinking about the emissions and using space technologies in a way to meet this balance of equitable energy, but really ensuring that we're deploying energy strategies in a way that is not going to lead us to emissions to a point of 1.5 degrees Celsius. And we use space technologies, one, to assess the measurements and the strategies in which we put in place, but also how we track these technologies. One thing that comes to mind and something that's very dear to my heart is the 17 Sustainable Development Goals. So we are now halfway to meeting our goals towards the SDGs. And of course, each SDG has indicators and metrics. And there is a way that we can use space technology in order to track and monitor how we're progressing towards these goals. So it is fundamental in developing and adopting strategies that are going to be sustainable to Earth, but also helping us to monitor and quantify and verify how we are doing with implementing these strategies.
Brilliant. Tom, what do you think, from your perspective, knowing that you look at sort of the space weather scene, you know, how is that going to be accessible? If satellites all of a sudden move about a bit or some drop a bit lower, should people care that much? Or if these things really got blanketed out like in some sort of Carrington event, then, you know, why should people care? Because I think that's the kind of the problem that we suffer at the moment, is that, you know, if you didn't get GPS on your phone, your car, GPS didn't quite work, you know, would that be the end of the world to people? Oh, maybe it would.
You know, you've hit on a couple of different issues here. One is that there's a lot of space technology we rely on, and it's in different orbits, so not all of it is exposed to the same threat scenarios. So GPS being in MEO, or medium Earth orbit, far outside of most or any space weather effects from the upper atmosphere, for instance, is not really going to be threatened by any major space weather event. And even in some of the particle, the major space weather events which have extreme energetic particles coming from the sun, which can irradiate satellites and perhaps damage them, the GPS satellites are extremely robust, and we don't so much worry about that in terms of threatening the GPS system. So the GPS system is fairly secure. It will be there. The question is, can it transmit through a cloud of debris if LEO is a complete cloud of debris, in the worst case Kessler syndrome scenario that we were discussing earlier? And that's kind of a TBD question. The other thing that I think is interesting, you hit on the geobelt as being kind of one of the key areas we do a lot of climate and weather observations, and that's true. Two things about geo. One, it itself is getting more crowded. So we are starting to worry now about collisions out in geo, even though it's a much larger space by volume, but it is a sort of they're all sort of in the equatorial band in order to make that geosynchronous orbit perfect. And so it's getting pretty crowded up there as well. And second, the geobelt observations of the climate and weather are really sort of what we would call in the business nowcasting. For instance, the GOES satellites up there that take the pictures of the hurricanes coming in, that's all very interesting and good for sort of nowcasting and emergency tracking. But the long-term, and in particular the forecasting observations used in weather and climate prediction, are all made by LEO satellites. So those are the polar orbiting LEO satellites that are down at 800 kilometers, right in the thick of things, the most crowded neighborhood, making the key measurements, thousands of millions really per day, that go into our weather and climate models, so we can understand what's both coming in terms of weather and what's evolving in terms of climate. So those are, again, if we were to lose those satellites because of increasing collisions in LEO, uncontrollable cascades of collisions in LEO, if we lose our LEO weather satellites, that's our weather forecast gone. That's our climate monitoring gone. GEO can't really help you there. We could do some from GEO, but for the most part, it's the LEO satellites that make the key measurements. and they are indeed threatened. So I don't think anybody wants to see that happen. I think it would be a major impact on society for weather forecasts to go back to what they were in the 1960s, where balloons and, sort of measurements of local temperature were all you had. So I really hope that we don't come to a Kessler syndrome and that we continue to do the environmental weather and climate monitoring that we're doing now, and of course do even more of it to make sure that we do achieve these goals that Manu talked about.
So I want to shift gear now and talk about perhaps some of the people that use space, because I think, historically, from the late 50s, the whole cloud of debris that we have now, much of that is historical. And many things that people don't know is that many of these things are old rocket bodies that still have fuel in them, and it's those that fragment previously. And so lots of organizations that track these things are often looking at these rocket bodies and then trying to figure out how we then assign, I don't want to use the word blame, but liability, and how that works in an intergovernment kind of world order type of way, when not everyone is necessarily friendly with each other, knowing what spacefaring nations actually exist in our current world. But there's this big rise, as Minu had said, in commercial ventures doing this. And of course, they're the sort of large operators that we have now. And do you think that this is perhaps a good opportunity to now bake in some good behavior here to maintain that safe environment? Or do you think actually these are people now that are perhaps monetizing space actually at the cost of eventually what the taxpayer may then have to foot the bill in? I've kind of complicated lots of things there into one question. And maybe, Minnie, you might have some opening thoughts on that, perhaps to start.
I have many thoughts on that. And, I want to pick up on the words that you said about good behavior, and talk about a project that we launched with a consortium between MIT Media Lab, ESA, Bryce Tech, the World Economic Forum, and now with the EPFL eSpace Center, and thinking about good behavior and good actors. Now, we live in a world of rating systems. So if you wanted to choose a restaurant that you were going to this evening, you would look on Google and see how many stars that restaurant had. Or if you are using Uber or Lyft, there's a rating system. And we realize that many industries have rating systems to really establish sustainable behaviors and sustainable practices. One such example is in the green building space. So there's the LEED rating system or the BREEAM rating system if you're in the UK, really thinking about how sustainable a building infrastructure is. So we thought, what if we take this idea of a rating system and try and apply it to the space industry? And in talking with both commercial but also government actors in space, we realized that there is a want to showcase sustainable behaviors. And to your point, Chris, I think that there's a greater need for the carrot rather than the stick in this. And so we developed what we call the Space Sustainability Rating, which is built on a model that really allows points to be awarded for missions that operators have, and also allows a common definition of what space sustainability actually is. So it's a clear way to demonstrate decisions that operators can take, but also their operations while in orbit. And it also considers what standards, international standards, these missions are abiding by, and what their end-of-life strategy might be. So a way in which we can really showcase, so, a mission might get a platinum or a gold, silver, a bronze rating, something that's public-facing, that showcases what operators want to do. And I have to say that we have seen a number of commercial companies really step up and want this initiative, want to be involved in this. It also has two additional, I'd say, byproducts of advantages. One, it offers a bit of peer pressure. So to your competitors, it showcases, what level of sustainability that private actor is pursuing. And it also provides some economic incentives. So we've been working with insurance companies, space insurance companies, to see how we might be able to provide these economic incentives. We also see a number of private sector actors really taking the step forward to sign up to voluntary mitigation guidelines that are really industry-led, again, to have a base sustainability strategy. And so I think that while there are increasing number of private actors, and we absolutely need that with the space industry, the private industry is not waiting for sometimes these slow governmental policies to take shape. They're really leading the framework and the initiative to be sustainable and showcase their sustainability strategies.
So for yourself, Tom, then, working with then obviously more and more industry, I guess, nowadays, do you see that these behaviors change, or do you think they play lip service somewhat?
I think it's a process of becoming more aware of what's up there and what can happen. And so there is going to be an incentive to protect your assets that you've launched now and in the future against, as you mentioned, what's been launched since 1957 and is still up there. In terms of, I think, addressing the problem directly, as Minu mentioned, there are commercial companies now offering debris removal, but we have really yet to see that demonstrated at all, and especially at scale. And that's, I think, a real issue. And when you talk about scale and also the issue of responsibility and liability, I really do think there has to be a role for government and intergovernmental policy bodies like the UN to try and negotiate with these large, essentially the countries that have produced most of the space junk to date, namely the United States, Russia, and to some degree China now as well, to figure out ways that we can have them, with their much larger resources, apply methods to address removal of some of the most dangerous objects up there. And so while I applaud the commercial efforts and I hope they grow and succeed even more, I really do think that there needs to be a governmental function here, both on the policy side to decide these responsibility liability issues, hopefully get an agreement as to who can apply resources on a government scale to go up and try and address some of the more egregious objects that are up there, namely the large rocket bodies that are tumbling and full of fuel, as you mentioned, and are very difficult to imagine dealing with. But I do think it's going to be a whole of society approach, really, that includes government with the big expenditures for the big objects that they've put up there and should be thinking about responsibility for removing, and the commercial industries coming up as well, as Manu said, with new sustainable practices going forward and that will hopefully reduce the problem for the future generations.
So I think the thing that really worries me about kind of this whole question of how the private sector participates in space sustainability is that I wonder whether or not that carrot is working at all. And that there are companies that can sign up to guidelines. And of course, we have some from the IEDC about everything shall deorbit within 25 years. And yet governments still give out space licenses for orbits where they could last centuries. Or they don't have then the practices needed to then guarantee that they will be put into low Earth orbit, ones whether or not they have a drag sail or they use their propulsion systems to then bring themselves down. So I think the people play very hard and fast and loose with some of these things because there's economic pressures in day-to-day life that people need to pay mortgages on the ground. And that's a big motivator when you're looking at GDP, when governments are going, buying big contracts from certainly sort of the larger, more established sort of space players that we're all familiar with. And so I really worry if some of these are too big to fail, and that we don't we don't think enough about the stakeholders here in space sustainability, which is actually taxpayers and the general public. And more often than not, that shareholders win out, because companies are there to make money. They're not there to make the planet greener. So I think it needs a mix of all those things. And so we'll see perhaps, I think soon, as to whether or not this stuff comes to play, and whether or not a bad rating for a given company will actually matter, because I don't think we're necessarily that cohesive enough just yet myself. And that's a real worry for me, because we see that the planet is mostly either under fire or underwater, sorry, or on fire, and we still can't do anything about that, and it's literally destroying people's homes. So if we can't deal with that, I don't feel too secure about what we could do in the future. Now, I think the thing that does make me feel quite pleased about everything here is that most people in the space industry acknowledges this, and actually we're all a sensible bunch, really. So we know the direction we need to go, and I think if we give people the right excuses or the right economic framing to that, we can definitely nudge them into that right direction, because this is, as Minu said, these behaviors I think are critical. But unless we can observe it, we won't be able to point it out. So I think, if all of a sudden we had radar stations and assets on the ground that people started sharing to go, hey, look at this behavior. We knew there was a conjunction and you literally did nothing about this. And it became known that behavior is severely frowned upon. The question then is, does that then not translate into government contracts or new business from other people? And so I think there's lots of new people that are coming in, younger people as well, that are coming into this, that certainly have those higher ideals, but I think they're going to struggle against the big, more established players. So we have to think about what could go on there, to then figure out how we help them, how we can grow these ideals and behaviors and nudge those people in the right direction with as not enough stick and as much carrot as we can perhaps possibly afford. And that can bring us nicely onto perhaps then the socioeconomic things that we have as well, because I think we, as countries that are emerging, they aren't necessarily signed up to the 4 space treaties that perhaps all of our countries are all signed up to. And there are European countries that aren't signed up to those things. So if you were a business and you wanted to say, for instance, go mine the moon, do something and put up another 10,000 LEO satellites in there that are tracking something that will make you money, why would you choose then to operate perhaps in other more established countries? Is that bad rating that important? Or do we think that, space is not necessarily something that should be accessed to if you aren't going to be using the environment properly? Maybe Minu, you're from an academic institution. Maybe you would like to be controversial here.
Oh, that's a bit of a hard ask. But I think you have a good point about going back to your point about more carrot than the stick. And you talk about new players that are coming onto the scene and whether they should have access to space, but on the proviso that it is going to be a responsible use of the space. Now, I will say I have been part of the UN system before joining MIT, and something that I'd like to keep up to date with is the number of member states who are stepping up and joining the conversations about space sustainability. In particular, we can look, and Tom mentioned this, to the UN with the Committee on the Peaceful Uses of Outer Space, UN COPUS. And it's interesting to note that in just the past decade, COPUS membership has risen by 40%. And it continues to be one of the biggest committees of the United Nations. And what we're seeing is that more and more emerging space nations are stepping up to have membership. So recently we saw the Dominican Republic, Rwanda, Angola, and Bangladesh, amongst many other delegations joining. What we're also seeing is many countries who are coming together to really utilize the platform of COPUS in order to help their own national sustainability strategies. So a couple of years ago, we saw Australia, New Zealand, and Nigeria, who, are defined as these emerging space nations, joining with established nations like Canada and France, the Netherlands, and the US, in order to propose a term of reference methods for work and a work plan in order to establish the next iteration of the working group on the long-term sustainability guidelines. So I feel more and more countries are realizing and acknowledging their need to build indigenous capabilities to utilize the space environment in a very responsible way. And I can give a couple of examples of this, but we are seeing the really push and the broadening of the table for these actors to come and have a voice on these very important issues.
So do they have all the same problem though? Because I guess, for a country like the UK or the US that is established in how it operates in space, how it regulates space, what does a new country like Nigeria or the Dominican Republic, do they solely adopt things? Are they picking and choosing? Or what are they doing?
So it really is a combination of the two, and it's hard to compare apples and oranges or established and emerging space nations, right? So the two biggest challenges that emerging space nations have is budgetary constraints, and second, capability building. So of course, very different from the US, China, Russia, India, etc. But what we are seeing is these emerging space nations really think about space sustainability on both a regional perspective, but also a national perspective. So I can give you an example. On a regional perspective, what we're seeing is within the Asia-Pacific region, there's something called the National Space Legislation Initiative, NSLI. And this is countries coming together to really implement a regional framework for the Asia-Pacific region under APRSF, which is the Asia-Pacific Regional Space Agency Forum, to coalesce on ideas and priorities that they want to present to COPUS as a region. But we're also, as I said, seeing this on a national level. We have countries like Thailand who are developing their national space strategies, but prioritizing space sustainability and responsible use of space. So we're seeing this in many different forms: international, regional, and then downstream to national as well.
That's super interesting that the more that we talk about space sustainability, the more my mind goes back to some of the challenges we have or synonyms we have with climate change, and particularly around money that you talked about, because they must be able to know the history between the sort of large players, and whether or not that word of sort of remuneration comes up perhaps in the same conversations that they have perhaps in climate change, but also in capability building as well. And in these conversations that you have with them, do you know whether or not the bigger players are coming through with this, or whether or not, we're still kind of struggling to get ourselves out the gate on that?
So this is a delicate conversation, absolutely. And I think that, we can't really respond to this without bringing in geopolitics into the conversation. And I think that we're at a stage that this is constantly evolving. We're seeing a lot of emerging countries partner with established space nations to build their capabilities, to leverage space capabilities that have already been formed. But as an emerging space nation, there's really no established ties or that they have to go through. So they're really at a very different starting points. But we're seeing more and more collaboration around the space. It makes me think of the Artemis Accords. And so just at the end of last year, we saw a number of countries that signed up to the Artemis Accords, Nigeria and Rwanda, who again would be defined as established space nations. But by working together, I think it's this leveraging, but a broader collaboration regarding sustainability, both space sustainability and then sustainability regarding exploration.
That's fantastic. Really appreciate your comments there, Minu. Tom, do you think that we've got the economics right sufficiently well enough such that we can go ahead and do some of these goals in space sustainability? Or do you think we over rely on governments, or do we count too much on industry just doing the right thing? Where do you see that we could really make changes?
That's a very good question. I am, as you probably surmised from my last answer, a little bit suspicious of just saying the commercial industry will blossom and take over and solve all the problems, because as you noted, they are at the end of the day a profit-driven industry, and therefore it's hard to see where you're going to make money. For instance, either mitigating space debris now or increasing space sustainability in the future. So I tend to come down on the side that it needs to be governmental agreements at the top, and perhaps it then through regulatory or incentive mechanisms trickles down to the commercial side, where they can then find a niche where it is somewhat profitable for them to operate. But for instance, if you look at the debris removal question, we see, as we noted earlier, companies are already trying to do this. They're launching satellites, but they're also immediately coming to governments and saying, do you have large scale contracts for us to sign up for to do this? And the governments are saying, well, maybe, let's talk. So I think it really does have to start at the governmental level. I am encouraged by what Manu has said in terms of more and more countries signing on to the UN Copious Accords and policies in order to become part of the conversation, because that's really what we need. We need everybody to be in the conversation from the start. If you're a new nation thinking about getting into the space business, you should be at the beginning trying to integrate sustainability and environmental concerns into that. Even though, like climate change, one of the arguments that they legitimately can use is, well, the established countries didn't have to do that. Just like coal-fired powered plants, those are the cheapest, easiest ways to get your country onto a very quick and easy energy increase path. We did that in the United States. All of the established countries used coal-fired power plants for decades, centuries, to establish where we are now. And now we're saying to these other countries, don't do that. It's a tough argument to make, but it has to be done. And I think the only way to do it is through very tough but open discussions at the UN type of level. And then again, hopefully the commercial side will come along with that as the incentives begin to arrive from the government level.
And I think the thing that worries me quite a bit in this is that sometimes we're not quite there yet on the government side, and that we can do this work. So one of the missions that I've been involved in is one called Remove Debris, rather aptly named, which had a net on it, and it would tested harpoon technologies as well as LiDAR as well. So this was a microset that was built here at Surrey. And then when you look at companies that are then trying to then move this forward and then to try and commercialize these things, like you say, Tom, there's not necessarily the business there that they can then put this investment into. And so missions that you might then go, okay, we wanted to take down this piece of debris. It's only until we put a number big enough that starts to worry a government, or a time frame that is short enough that it then becomes a political problem, that it happens on someone's watch. Because I think there are nudges that need to happen, not just in the commercial sector, but also within government as well. Is that if we need to do something, they're kind of counting on academia and industry, like you say, to come up with some of the solutions, and actually for some of them to come up with the money as well. And I don't think that necessarily pays the bills for everyone. It doesn't mean that people can get through their lives and pivot onto perhaps some more of these greener and sustainable challenges. But it's not to mean that it's not impossible for, I think, some of the larger countries. I think what we need to do, certainly from where we developed from is to perhaps reprioritize some of those things. And so it's great to hear Minu talk about them putting sustainability at almost the top of their registers and what they might need to do for funding of it, because they acknowledge that in the future, this is just a liability that they don't want to own as a government. And I think we could perhaps do better, certainly for the more established players, in then putting more focus on sustainability and developing that technology with academia and industry, to then get things to a point where you can go, hey, if we had that problem in GEO, do we actually have someone that can go and sort that out for us? Rather than going, wow, it's been too much of a slow start. So I think we can accelerate that perhaps whole section as well. So the next perhaps part that I want to ask everyone is about how we then use technology in this. Like, and if there is any particular technologies that we're either over-reliant on, or whether or not then we need to develop very, very quickly. Do you have like a top technology that just we are either underutilizing or doesn't exist yet that we need to come up with in the next short term? Maybe Minu.
I'd actually like to hear Tom's response on this, because he talked about tracking, and I think that is certainly a technology in my eyes that we need to put a lot more funding and effort into. So many people say you can't manage what you can't measure, and in this case, you can't manage what you can't track and identify. So, but Chris, I just want to come back to your point before I give the floor to Tom, talking about government support in the private sector to develop some of these technologies. And two things come to mind. You mentioned that it is capital intensive, so that upfront capital to develop and scale these technologies can be quite daunting for a number of new up and coming and probably some entrepreneurial companies. So establishing frameworks and avenues of funding from governments to support the initial capital, I think will go a long way. And then second, what comes to mind is the long lead times in from the demonstration phase to the scale-up phase. And so taking into account that time frame as we develop these technologies, and again, really thinking about how governments can support that. But Tom, I'd love to hear from you what technologies you think that we, academia, but also industry and government should be really like honed in on.
Well, I'm somewhat biased, as you can imagine, towards environmental measurement. And one of the things, as I mentioned earlier, that we have trouble with is we don't have the technologies available to measure and nowcast the LEO environment, which is the most rapidly changing, the most affected environment, to know, for instance, when a geomagnetic storm strikes, what is actually happening up there. We don't have the technologies to monitor the environment. And we also don't have the technologies to forecast the environment, because ideally what operators would like us to do is tell them in the next 10 to 12 hours, your satellite is going to drop by 10 kilometers in altitude and therefore be out of track by another 100 kilometers or so, something like that. We're not even close to that right now. We have environmental models that we run that simulate the thermospheric environment. And it's to some degree simulates the thermospheric environment during geomagnetic storms, but they are very far off of reality because there's no data assimilation in them. It's much like your weather models, which are these huge, very complex numerical simulations of the physics involved, which are amazing in and of themselves as in terms of technological development. But if you were to run a weather model without the data assimilation from all the satellites we talked about earlier, and the balloons and the surface temperature measurements, that model, even though it had tremendously fantastic physics, would give you a terrible weather forecast. So that's where we are in the space weather forecasting enterprise right now. We have fantastic models. We understand a lot of the physics, although there's more physics to be understood. So that's where a lot of research needs to be done. But even though we have fantastic models, we don't have enough data assimilation to make those models accurate at all. And so we're really at a point now where we need to start thinking about how to, and it unfortunately does take launching more things into LEO to make measurements of that environment, but that's just the reality. We need more LEO satellites making precise measurements of density, temperature, and environmental variables that we can then feed into a forecasting model. and try to get to the point where we can accurately forecast the space environment, say 3 days out. Then you can take that model and integrate it into a tracking model and have some hope that you can actually know where your satellite's going to go when the environment does things that you don't expect, like start an extreme geomagnetic storm, for instance. So right now we can only give sort of very crude warnings. Here comes a large solar storm. It's going to cause large effects. We know that. We don't know what how large those effects are going to be, though. And we can't really forecast for you how long it's going to last, how severe it's going to be. So I'd really like to see technological development in that direction so that we can, again, characterize and predict this environment that we're operating in. Because as Manu said, if you can't characterize the environment and ultimately if you can't predict what's going to happen, you really can't manage the environment or any of the assets in it.
So being slightly controversial then, I mean, if you haven't measured it, does the risk exist?
Oh yeah, we do know that it exists because again, back in 2003, all of the LEO satellites were lost, and it took 3 or 4 days to reacquire them with radar and reestablish that catalog. So we know that in a big storm, things are going to move around. Back then, it was just a big surprise. There was not even a model that was running that was really even accurate to any degree. Now we have models, but they're not accurate. So we have a shot at telling people, okay, we know big things are about to happen, and here is how big we think it's going to be. So get ready to try and relocate your satellite. It's going to be, as I said, X kilometers lower, X kilometers ahead of where it's supposed to be. That sort of thing is where we need to go, and we're not even close to it yet. And if we don't get there, then we're just going to be into the situation we were in 2003, where it's all just a big surprise, and people have emergency operations around the clock for 3 days trying to figure out where everything is. And luckily back then, to our knowledge, there were no big collisions, but space was, as mentioned, an order of magnitude less crowded back in 2003 than it is now. So, and it's not if, it's when we get another one of these big storms. We are going to have to deal with these, things moving around a lot up there. So that's where I think we need a lot of development. Also, quickly reacquiring these things is going to be crucial because, as you may be aware, these operators of mega constellations don't control individual satellites. Starlink is not sitting there with 3,000 operators, each operating 2 or 3 satellites. They're operating autonomously. So how do they do that? They send up the catalog, the known orbital catalog, to each satellite, and it makes autonomous calculations. Now, what happens when that catalog is completely wrong? What do you do? What do you tell the satellite to do? So that's sort of the technology of autonomously operating vehicles in highly uncertain situations, I think, is something that hasn't been sufficiently developed as well. Right now, they're sort of operating on this, hoping that everything is correct in the catalog. They're basing their operation on a large amount of hope. Let's put it that way.
Yeah. And it's interesting how you mentioned Starlinks there, because obviously, very recently they lost a whole rocket full of their own Starlink satellites because of this effect of increased drag due to the solar conditions that they had. And
Right.
For those that kind of work in this arena, you're going, well, of course. But for a company of that size to be kind of blindsided like that is not a good place to be, because you feel like we should know this stuff by now. Interesting. So there's something that Minu said that was interesting about capital spend, and it not being enough. And I think the real worry that I have again around sort of nudging behaviors is that this is taxpayer risk anyway. So we own the risk now, and you might be able to put a number on that, whether it's something that the World Economic Forum does or the UN does, how it puts a number on however many conjunctions that Starlink has with itself per hour, and how they put a number on that, then back to the US taxpayer, if something does go wrong, is quite an interesting economic area to try and figure out. And so I think Tom and Mina probably has said both the right things there, that we need more policy in this area, and that before perhaps we hit any tech, it's going, well, if there is a coordinated object with perhaps an unknown or an uncoordinated object, or one that is older, that may have been from a piece of fragmented debris that maybe hasn't got a flag stamped on the side of it, how do we go and capture those things, especially when we get extremely worried about them? And we kind of go into this sort of realm of having something that is coordinated, as in sort of it's known, and then we have something that's perhaps uncoordinated that we may not know who it is as well. So that cooperation loop there is the thing that I think would be tightened first, because we cannot start talking about interface plates or standardization of processes such that it can be autonomously done until we can kind of iron out quite a lot of policy about how these governments work with each other. Because even though there might be these companies that operate in certain countries, ultimately the risk is owned by the taxpayer if the company goes under. And so what do you feel like is the right balance between those things? Because what we did in the UK a number of years back now is we put in something called government indemnity insurance. And this kind of then is a pot that is meant to be growing, that kind of is meant to cover that, so that the UK accepts that it might be doing more risky things, and it's starting to kind of save away for, if and when, it runs into problems. Do you have similar things happening in the US, or are there policies that you wish existed?
So I can maybe start there, and I can't speak for absolute policies of the US or any other countries, but I do want to underline the importance of policies, but also the challenges, right? So there's something that I term in my research called the pacing gap, which is the exponential emergence of technologies to do with space sustainability, but also the progressively slow consensus base when we're talking about UN corpus on coming up with these policies. From the very initial conversations of the long-term sustainability guidelines to the guidelines being agreed upon, there was about a decade there where many activities were happening. So I think that there needs to be a balance, as you said, Chris, between how do we engage policies, but also not deter the technologies that are helping us launch these satellites, but also helping us be responsible in space. I think more than policies, we need avenues of collaboration with regards to policies. So, we see initiatives such as the net zero space, for example. There are a number of companies that signed up to that, and a number of emerging space nations and space agencies. Azar Cosmos, for example, was one, as well as the Egyptian Space Agency. So the more and more, in my view, that we develop these initiatives and avenues to talk about policy, but also the challenges of long-term policy development is absolutely crucial.
Yeah, that's fantastic. So one of the last things that I've been thinking about myself as we've been talking about policy is actually how we could perhaps be individually nudged. Myself as an academic, we are pushed to do papers, and we're pushed to do data sets and pushed to do things first. And I'm wondering whether or not we could perhaps do more ourselves to perhaps open up data or open up processes. Have we got something like wrong in the way that we've sort of manufactured these systems upon systems, such that then we can talk the big talk around sustainability, but as a university, I'm pushed to do certain thing or bid in a certain way or do a mission in a certain way. Have we lost some sight in that? Do you think that just our local problems are going to win out because the reality is just, everyone needs that paycheck? Or do you think that our individual companies and organizations could do more to help us achieve those goals?
Well, it's we keep coming back to this issue of individual incentive versus the issue at hand, which is an issue of the commons, and how do you take care of the commons when individuals want to operate in it for their own uses. And I keep coming back to the analogy of, and maybe it's not a perfect one, but of space being like the oceans. There is a commons there, and everybody benefits from having healthy oceans. And yet it's very easy for an individual operator to go out and just neglect any sort of responsibility and dump bilges and do whatever they need to operate most efficiently and most profitably for their individual ship. Now, I view space kind of the same way. And therefore, I think that's an optimistic view because we have centuries of dealing with the oceans and those policies. And I'm not a policy expert, so I don't know if this is really talked about much, but it does seem to me that it's a hopeful thing to look at in terms of people are really starting to be aware that the oceans are a finite resource, as orbital space is. I think orbital space used to be viewed as sort of it's space, it's infinite, it's huge, there's no limit to the amount of things we can put up there. And that has obviously now been shown to be untrue, especially in LEO. And so we have a resource that was previously thought to be infinite. We now know it's finite. We now know everybody needs and wants to operate in it. And how do we do that most responsibly while also honoring individual initiative and recognizing the ability that you got to get, at the end of the day, you have to get the job done and you have to get a paycheck, as you say. So it's not really an answer, but I think it's maybe a good analogy to start looking at and perhaps explore more.
And if I may build onto what Tom said, really great points. I think that it's our responsibility in academia to also raise awareness outside of the scientific and academic community. Space sustainability is not a space industry challenge. It is a everybody challenge. And so we, as much as we love to write papers and publish in journals, we need to be projecting this and making this issue accessible to the general public. So they in itself, as you rightly said, Chris, it's taxpayers' dollars, can apply pressure to governments who then apply pressure to the private industry. And so it is going to be a closed loop system.
Perfect. Well, thank you so much for your time and for spending, your part of your day with us today. Hope to see you all again soon.
Thank you very much. It's a great opportunity. I appreciate the opportunity.